Hello everyone, this is Galen and I'm going to be doing your last lecture for the last lab today. We're going to be talking about plane and curved mirrors and ray tracing. First, we're going to talk about some terms that you're going to need to know for this lab. First, we're going to talk about parallax, light rays, object, and what an object distance is, an image, and an image distance. All right, parallax. Parallax is an apparent shift in the position of two stationary objects relative to each other as viewed by an observer due to the change in the observer's position. As you can see in the picture, if you hold your thumb out and you look at something in the distance, you can either change eyes or move your head back and forth and you'll see that everything moves relative to everything else. And you can often tell if something is in front of or behind your thumb based on how it moves. Light rays are an idealized model of light in which individual lines of sight are drawn as straight lines. As you can see in the picture, this makes it really easy to see what is going on in an optics scenario. An object is anything that is being viewed. It doesn't matter if it's yourself, something else, a pencil, pen, a candle, you'll see all kinds of things. In the lab, you'll be using nails as your objects. Now the object distance is the distance between the object and the reflective surface of a mirror. In the case of most normal mirrors, you have a piece of glass with a silver lining at the back. The reflective surface is the silver on the back of the glass, not the surface of the glass. An image is the likeness of an object produced at a point in space by a mirror, lens, or other optical device. You'll get to see how the image appears in a specific spot, how you can use parallax to find that image position, and whether it's an actual real image or a virtual image. Like the object distance, the image distance is the distance between the image and the reflective surface of a mirror. The law of reflection is the equation that you will be using the most during this lab. And it simply states that the angle of incidence equals the angle of reflection. Now theta, your angle of incidence or your angle of reflection, is measured from the normal or the perpendicular line to the reflecting surface. It is very important that you remember that theta I equals theta R and that they are measured from the normal. You will be doing this quite a bit during the lab. The reflected image can have several characteristics. The type, it could be a real image or a virtual image. It can be enlarged, reduced, or even possibly the same size. The image can be upright, inverted, or laterally inverted. Real images are where light rays converge and pass directly through the image. For simple optical situations or setups, it is always inverted. As you can see in the picture there, it is inverted. The light rays actually bounce off the mirror and converge to a point on the image. Images are where the light rays diverge once reflected and never pass through the actual image. For simple optical situations, it is usually upright. Notice that the dotted line on the other side of the plane mirror there, this is a virtual ray, which leads to a virtual image. Magnification happens when the image is larger, smaller, or the same as the object. It's simply the ratio of the image height to the object height. If it's larger, we say it's enlarged. If it's smaller, it's reduced. And of course, if it's the same size, then it's the same. The image can also be upright, inverted, or laterally inverted. Upright means that it's on the same side of the central axis as the object. Inverted means it's upside down, and laterally inverted would be that it's flipped left to right. Laterally inverted would be what you would see in a mirror. You would be upright, laterally inverted. The first thing we'll look at will be plane mirrors. Plane mirrors are the flat mirrors like you have in your bathroom or possibly on your bedroom wall. And they have certain very simple properties. First is that the image distance is always the same as the object distance. So if you're standing 3 feet in front of your mirror, the image will look like it's 3 feet behind the mirror. Also, the image height is exactly the same as the object height. Next, we'll look at curved mirrors, which we'll look at both concave and convex mirrors. Curved mirrors have a focal point, a vertex, and a focal length. The focal point is where the light rays meet if they're coming in from infinity, so the light rays are parallel to each other. The vertex is the middle point where the principal axis crosses the reflective surface. The focal length is the distance from the focal point to the vertex. The focal length is always 1/2 the radius of curvature. Whether you're dealing with mirrors or lenses, you always have principal rays. For mirrors, there are 2 main principal rays that we'll be looking at for the lab. One is the ray that runs parallel to the principal axis and then reflects through the focal point. Ray 2 goes through the focal point first and then is reflected parallel. Where those 2 rays intersect will be where the image is. You can also use a third principal ray, which would be reflected at the vertex, where the image of incidence equals the image of reflection, and it should go through the exact same point also. Next, we're going to look at 4 cases with concave mirror reflections. These you don't have to necessarily memorize, but you do want to be familiar with what is possible. And so that whenever you do solve these, whether it be in your lecture or you solve them here, you know what you can expect. Okay, in case 1, the object is greater than 2 focal lengths from the mirror. This means that the object is placed further than the center of curvature. It will be a real image, it'll be reduced, and it will be inverted. In case 2, the object is placed between the center of curvature and the focal point, in which case it will be the same except it will be enlarged instead of reduced. In case 3, the object is placed at the focal point. And when this happens, there can be no image formed because the light rays never converge or diverge. They simply go off to infinity parallel to each other, never to meet. For case 4, things get a little bit strange because it's inside of the focal length. The image will end up on the other side of the mirror, so it will be virtual, enlarged, and upright. Now you notice that the parallel ray comes off the top of the vase, it goes to the focal point. But whenever you look for the image, because the 2 rays, whenever they leave the mirror, they're going off in different directions, they're diverging. So what you have to do is backtrace them. When you backtrace them, you just kind of draw a dotted line going back the opposite direction of where it took off to. So this is after the reflection. You'll backtrace. And you'll see that it's virtual, enlarged, and upright. So just like our rules that all virtual images are upright and real images are inverted, that's shown right here. Next, we're going to talk about convex mirrors. These are the mirrors that you would see up at the convenience store so that they can try and catch people shoplifting. Or maybe they're up in places where you can try and see around a corner. Here we have the ray diagram for the convex mirror. And as you see, the first ray, ray 1, travels parallel and then is reflected It can't go through the focal point, so it reflects from the focal point outward. So you see, you can start at the focal point and then draw a line up through where it contacts the mirror, and that will give you your first ray. Drawn from the tip of the arrow to the focal point, but whenever it reflects, it goes parallel. So you draw the line parallel to the principal ray, and just make sure that you draw it both directions so that you get your virtual ray on the other side of the mirror. Of course, your virtual image will be where your two virtual rays intersect. All right, so this is the end. So if you have any questions, please ask your TA before the beginning of lab. Remember, as always, all of the questions for the rat will come from this video. So if you're not sure of anything, please ask your TA. Thank you very much. You guys have fun and good luck.